So we're off into 4-9. You want to settle in and get comfortable with what we're doing, because 4-9 is the same as 4-10. 4-10, we'll spend 2 days doing homework there. So there's 3 days that are essentially the same thing. So I won't sugarcoat it for you. These are usually a challenging group of lessons. Along the lines of the percentage days that we did, I think the general perception on the percentage days that we did were the lessons seemed understandable, and then when you got into your own time and places, it just seemed harder. Like, it seemed easy in class to get the tables set up and make the equation and solve them. It was like, oh, this isn't so bad. But it was harder to do in your world than in our world. And I think that may be the case again. But these problems share with the percentage problems the idea that organizing the information in a table is usually helpful. So I've got a page of notes where the tables are preset for you. We'll work our way through these. We'll spend the next couple days trying to work out the details on this. But before we dig into that, there's a couple things you should know that I just typed for you at the top of the notes page. So one is that the relationship is rates times times always equal distances. That's just a true thing. That's called the distance formula. The distance formula tells you that rates times time make distances. Just to make sure we're clear on what these things mean, rates refer to how fast things are going. Usually has the word per in it. Miles per hour, meters per second, so on and so forth. But rates are a measurement of how fast. Time is a measurement of how long something takes. Might be hours, minutes, seconds, some sort of system of measurement like that. But if we're measuring how long it took to do something, that's a time. And then distances is a measurement of how far it is to get from here to there. It's miles, meters, kilometers, etc. When you first read any of the stories, you want to make sure that the words all match each other. So like if you have a story with minutes here and like hours there, you need to make sure everything is minutes or everything is hours.
Is the 1 to 7 due today?
Yes.
Okay.
These are probably the most famous algebra problems in the world. These are probably the most famous homework problems in the world. Anytime there's a sitcom that they're like, family is doing homework, this is what they're doing. Like, and they always make the same sort of joke, like, why did they just take the bus? Why did they walk? You know, one of those things. You know what I mean? You've seen those shows. But they're always like, why do we care about the train from Chicago, or whatever they're talking about? It's always this. So this has made an impression on American culture, I guess, every time. But here we go, doing some math. So 1A says 2 buses are leaving the station at different times. Bus 2 is leaving 2 hours later than bus 1. Bus 1 travels 40 miles per hour. So the 40 is the first number we want to try to get into this table that I set up down below. Is 40 a rate, a time, or a distance? It is a rate. So in the bus 1 rate box, that top left corner, throw a 40 in there. It had per in it, so that's a rate. That's how fast. Bus 2 travels 60 miles per hour. So that is another rate. Throw that in the rate for bus 2. So the rate stack, there's a 40 on top of a 60 in our table. Question about the rate stack? Time stack. You could do one of 2 things, and that's why I have a problem 1A and I have a problem 1B. For problem 1B, you might as well throw in the same 40-60 stack. It's not going to be any different. But what is different about how we treat the times? Okay, we don't know the times, so that has something to do with an X. I'm going to do a T for time, but an X would work just as fine. There's 2 ways we could set up the time boxes in these stories. We know what about the times? We don't know an exact number for any times, but what do we know about a little bit of time relationship? What do you know about the times of these buses?
Bus 2 is
Bus 2 left 2 hours later. So bus 2 is traveling 2 fewer hours. Or if you want to look at it oppositely, bus 1 is traveling 2 more hours. But they're both somehow involving variables because we don't know what either one is. Can anybody come up with a time pair that makes sense?
T and T minus 2.
We can go T and T minus 2. So let's do that for 1A, I guess. The time for bus 1 could be T. The time for bus 2 could be T minus 2 because bus 2 is traveling less time. That would make sense. What will be another pairing you could do for times, and we'll do this for solution 1B.
T plus 2.
We could do a T plus 2 for bus number 1 and do a T for bus number 2 because it's also true that bus 1 was traveling 2 more hours. So it doesn't matter which pairing you do. When you go to do a homework problem, some people might do the T plus 2 versus T system. Other people might do the T versus T minus 2 system. It doesn't really matter. They're both going to take us to the correct same answer. And then we're done table filling from the story tell. Question about the story tell table fill? How are we going to make our way across the table? It's the same way we made our way across the table before. Multiply. So what we'd have for the 1A, the way we set it up, 40 was next to T. So make a distance box, 40T. 60 was next to T minus 2. So either create a distributing problem, or if you're in the mood to do it, just distribute and get 60T minus 120. If bus 2 is catching up to bus 1, what's true about their distances? No. They both left the same station at different times, and the later bus is driving like super fast and is going to catch the other bus. So what's true about their distances when that happens? No, they're going to travel different times because the one got the head start. There's something true about their distances. They left the station, fast train leaves a little later, catches the other bus. What's true about the distance covered by the 2 buses? They're the same. It's the same distance. They've ended up catching each other. They're in the same place down the road somewhere. So we want to make the one distance box, 40T, equal the other distance box, 60T minus 120. And then let's solve that. If 40T is equal to 60T minus 120, can somebody solve that? Tell me what T would be.
What, 6?
It will be 6. I'll give people another little bit to figure that out if you need it. 40T equaled 60T minus 120. If you get all the T's collected to the same side, there'd be negative 20 of them. If you do a dividing, you're going to get a T of 6. Does anybody need help? T of 6. Then here's one thing that makes word problems aggravating, usually to students as they learn them. Just because you did math correctly doesn't mean you found the answer they wanted. 6 is the T. That's the time for bus number 1. Do they want the time that bus number 1 has been driving? No, they want the time that bus 2 has been driving. So if bus 1 has been on the road for 6 hours, how long has bus 2 been on the road? 4 hours. So grand total answer there would be 4. Question about that one before we go finish the other one?
Wait, so does 6 go in the...
6 goes nowhere. 6
okay.
is just like the answer. I guess 6 could replace T. in that time box.
Yeah.
But you don't need to put 6 into the table really anyway. The table is just to help us get organized at the beginning. So let's go back to the 1b. For 1b, we had 40 stacked on 60. We had t plus 2 stacked on t. We still want to multiply across. So if 40 distributes across, we get 40t plus 80. The other multiply across box would be 60t. And what did we eventually decide about the distances a couple minutes ago after a bit of a discussion? They're the same. So we're going to let 40t plus 80 equal 60t. If you solve that, you're not going to get 6. What are you going to get if you solve 40t plus 80 equaling 60t?
4.
4. And since the t is what we solve for, t is 4, the t is in bus 2's line, and you were asked to figure out how long bus 2 was driving, the answer is 4. It's a little simpler. The thing we solved for was the thing we wanted, so 4 is good. If they asked you for bus 1, you could have still come up with the 6 because it was 2 hours longer. 4 more than 2 is getting us the 6. But we were hunting the 4. Question about 1? So let's go do number 2. Number 2, there's 2 cars leaving at the same time. One car goes east, so probably label over on the left, label the middle square on the left column, put east there, just so we have an identifier. Across the top, put rate time distance. I didn't fill that part of the table for you, but we'd go like very, very top left, just leave it unlabeled. But then across the top, next to the unlabeled square, go rate time distance across the top, go east car in the 1 box on the left margin, and the other box, what's that? What's the other car doing? There's an east car and there's a west car. So we'll go east car, west car. Do you know the rate for the east car?
Yes.
Yes. What is that?
40.
40. Do you know the rate for the west car?
Yes.
Yes. That is
50.
50. What do we know about the times of these cars?
But we
We know something. We don't know a number, but we know something. What do we know about their times?
They left at the same time.
They left at the same time. So this isn't going to be like a t plus 2 versus t or a t minus 2 versus t. There's no head start in this game. They left at the same time. We don't know what that time was, but we know it's the same time. So both boxes this time are t's. Multiply across. 40t for one distance, 50t for the other distance. These distances are not equal. If we just think common sense for a second, the car going faster is going to go farther, and the car going slower is going to go less distance. These distances are not equal. Don't make 40t equal 50t. We're going to have to read around and understand what's going on. So maybe sort of peek at me for a second. Here's where we are at the start. The 2 cars are in the same spot. The one car goes east. The other car goes west. We don't know what these are. We just know that they're going to be different. But what do we know in the back to the story? What do we know in a distance way?
270 miles.
270 apart they're going to be. Is that what the one car did? Is that what the other car did? Or is that what the cars have done together to separate from each other?
Together.
That's together what they've done. So one car went this way, one car went that way. Their total separation is 270. So we're going to do something with these distance boxes, but they're not equal. What do you think? One car went that way, 40t. The other car went that way, 50t. Add them together. The equation here will be the 40t from the one car plus the 50t from the other car equals a 270. And then we're going to solve that.
30.
Not a 30.
Is it just 3.
It's just a 3. The 270 dividing a 90, like those zeros kind of cancel out. It's just going to be a 3. 3 is representative of the T. T stands for time. How long it takes is how long, the time question.
Yes.
Yes, so celebrate your 3, that's the answer. If I wanted to be meaner, I could have asked how far. What's how far about?
Distance.
Distance. So if I say how far east car, what would you do? Go distance box east car. We know the T is 3. So if I say how far did the east car go? What math would you have to do?
3 times 40.
3 times 40 is 120. If I want to know how far did the west car go, you'd go to the west car's distance box, because how far is distance, and do
3 times 50.
3 times 50, 150 for that car. I didn't ask you that. But in some other story, could the book, could someone ask you to like go beyond a step what we did? Yeah, they could. I could go back to number 1 and ask you how far the cars went. How far the cars went, we'd be looking at distance boxes, and you'd either be doing 60 times 4s or 40 times 6s. We could have figured out that the cars in 1 went 240. You weren't asked to do it, so I didn't bring that up till now. But if 1 had done a distance question, did I add that on? I think I did. It's not on my paper, but I think it's on yours. Did I add that on to 1? How far were they from the station?
Yeah.
Yeah, so I should have, it's good I doubled back and did that. How far they are from the station, we'd go distance boxes there. And you would go 60 times 4, or you would go 40 times 6. You would get 2 40s. Question about fronts? Here's the moral of a story. If you're not sure whether to let the distances be equal or not, if one vehicle is going to catch the other one, let the distances be equal. But if they're going to run away from each other or run toward each other, you're going to add the distances together to make a total. So again, if there's a catch-up move, let the distances be equal. But if they're running away from each other or toward each other, add the distances and let them be equal to each other. We'll go to the back. For 3, I set up a 3A and a 3B because there's 2 ways you could do this, and they're equivalent. Across the top, do our labels. The top left, just leave unlabeled. But then, what are the headings across the top? Who, and who?
Rate time distance.
Rate, time, distance. And I would keep them in that order, because as long as you keep them in that order, you can multiply across the table like you're comfortable doing. So rate, time, distance lets you multiply across. Then what's our scenarios here? It's not east versus west. What's going on this story? It's this versus that. What's up?
You and the trip
How's there 2 different journeys in this?
You go somewhere and then you go back?
Yeah, so top left corner we're unlabeled, but one of these lines label go there, and the other label come back. Something like that. So go there, come back. Do you know the go there rate?
Yes.
Yes, it is
40.
40. Do you know the come back rate? 50. So there's that. Trip back takes 30 minutes less. So you don't know the time to go there. You don't know the time to come back. But you do know that it's different by 30 minutes. So there's 2 ways you could set up the times on number 3, just like there were on number 1. Number 1, we did a t versus a t minus 2. We did a t versus a t plus 2. That's the kind of thing that we're going to do here. One of these boxes is going to be t. The other box, it depends on how you set it up. What's the other box going to do?
Subtract.
Could be subtract, or it could be
add.
add. It depends on how you're doing it. So if the go there box is t, is coming back taking more time or less time?
Less.
Less. So that would be a t minus. Common mistake is going to be to put t minus 30, T minus 30, I got you on a technicality. It's a good thought. T minus is true. Why is 30 going out the window? What's the H stand for? Hours. So MPH is hours. MPH again is hours. 30 minutes is not hours. That's going to cause us a problem. You can't mix and match a story, hours here and minutes there. So what we're going to have to do is convert that 30 minutes. What's another way your brain might think of 30 minutes? Half an hour. So we're going to go T minus half. So next to the 40 is a T. Next to the 50 is a T minus half. If you like decimals, do T minus 0.5. Doesn't matter to me. You do what you want to do. Let's not finish that table. Let's go to the other table. Other table, same rate time distance, same go there, same come back, same 40, same 50. But this time let's do the T's a little differently. Next to the 50, put a T. Next to the 40, did that car take longer or shorter, the 40 car?
Longer.
Longer. So do T
Plus a half.
plus a half, or T plus 0.5. In a homework, would you ever have to do these problems both ways? No. But I'm doing it both ways now to just show you you have choices. And if you go do homework comparisons, hey friend, help me with this problem, and they're doing an add, but you're doing a subtract, you might both be right. You might both be fine. Let's finish the one that we started first, where we had, was 40 next to T the first way we went?
Yeah.
Okay, so just go across. 40 next to T, so put 40T. 50 next to T minus half. That's going to be a distribute problem, so either write it as a distribute problem or just distribute it. It would be 50T minus, what's half of 50?
25.
25. So 40T in one box, 50T minus 25 in the other box. Now we're going to have to think. On the front, on one of the questions, the distances were
The same.
the same. On the other question, we had to take two different distances and add them to equal some other number that was in the story. If we're going there and we're coming back, are the distances the same? Yes. So we'll just make those equal each other. 40T would equal 50T minus 25. And try to solve that for T. Where we are on 3A, we got ourselves to a point, if you want to jot down, 40T was equaling 50T minus 25. And we're in the process of solving that for a T right now.
Is it 25?
That's close. The location of your decimal is a little bit off.
Is it 2.5?
It is 2.5. So 2.5 is T. T stands for time. They ask how far. Is how far a time? No. How far is a distance? So we need to go to a distance box, but we go there with the knowledge that T is 2.5. So we're going to do what math? What's the easier distance box to do the math on it? The 40T box or the 50T?
40T.
The 40T box is easier. So just do 40.
Divided by 2.5?
No.
Or times?
Times 2.5. 40 times 2.5 will get us there.
Is it 100?
It is 100. Anybody need help with that variation? Let's finish the 3B way. The 3B way, we had a 50 next to a T, so the distance box would be 50's next to t, go down the
50t.
line for 50t. 40 was next to t plus a half. If we distribute that, it would be 40t plus
20.
20. We decided that the distances were going to be
The same.
same. So 50t would equal 40t plus 20. Solve that, it's a whole number.
Two.
2. But it again asked how far. So how far, we need to take that time of 2 and step into a distance box with it and do the math that presents itself. I think the 50t box is easier. So we go 50 times 2, which is 100. It's the same answer no matter what path we travel. If I wanted to be nicer to you, I could have asked you a question like how long? Because how long is a question about time. The how longs, one of them would be 2, one of them would be 2.5. It would depend on what I'd ask. How long did it take to go there? 2.5. How long did it take to get back? 2, because it was half an hour less. There's a variation of those. Question about punching through this? Okay, your homework today is a little bit easier because they built this up in bits and pieces. I'm looking at 170. If you want to join me there, you can peek with me for this brief preview. 1, 2, 3. They set up the tables all the way already, and they told you the distances are equal. And all they want you to do is to do what?
Find the distance.
No. Write an equation. How would you write the equation?
Just go straight across.
They already went straight across. So the tables are complete. The distances they say are equal. How could you make an equation?
40t equals 55t.
Yeah, just put the one distance box equals the other distance box. Did they ask you to solve it? No, so move on. 1, 2, 3, that's like the greatest homework 3 questions you'll ever get. That's all you need. 4, 5, 6, they start you with the table. And then what do they ask you to do?
Distance.
They want you to like do all the algebra process all the way out?
Write an expression.
No. Well, sort of. 4, 5, 6, what's the goal? Where would you stop?
Distance.
Don't need to find the distance. What are they hunting?
An equation.
Nope. We're not good at reading directions. The directions for 4, 5, 6, first 3 words,
Complete each table.
complete each table. So all you have to do is complete the table and then bail. So the table is mostly there. How are you going to complete the table from where they dropped it off?
Multiply across.
Multiply across. So if you multiply across to finish the table, don't need the equation, don't need to solve it, don't need to interpret it, just finish the table by multiplying across. 4, 5, 6, call it a day. It's a little bit harder than 1, 2, 3, but not by much. 7 through 12. What do they want?
To solve the
Solve the equations. So they created equations like the ones we're going to get practice solving over the next 3 days of doing this, and you're going to solve the equations. So 7 to 12, that's like medium. We could have done those 6 problems 2 months ago maybe. Distribute, do opposites. There's nothing too fancy with that. The only problems you actually have to do, no, you don't even have to do these. What does it ask you to do in 13 and down?
organize information.
Yeah, make a table. Oh, they deceived you though. Because
Solved.
number 16 says, oh, now that you set them up, 16 says,
Solve them.
no, not yet. Write the equations. And then once you do, 17 says, solve them. So what I would say, I wouldn't look at 13 to 17 as 13 to 17. I'd look at it as 13 to 15. But they want you to do the table and the equation and solve it. Basically what we did. We did 3 problems on these notes papers. You're in the homework going to do 3 problems like we did on the notes papers. But start off, just make the equations. Middle group, just finish the table. a little bit of just solving. 13, 14, 15 do the whole shebang. So 170, whether you consider that 1 to 15 or 1 to 17, that's kind of a matter of your point of view.